Doesn't matter what kind of hexagon you use. A is just gonna be the same. It's just a constant. So the varying one is the height. So basically, you need to find dVdh, not dVdA. So dVdh. Okay. So need to find the second derivative. Is a dv square v dx square. Um, okay, let's look at how we do this. This is regular hexagon. So in other words, this, just so you remember, this is actually 120. So the exterior angle here is 360 divided by 6 lah. EMF stuff. So it's 60 degrees. So this is 120 lah. So try to understand this part here. So if this is 120, all of these are 120, 120, 120, right? 120 and so on. So you realize the first part is usually geometrical problems. So geometrical problems means that you don't actually have much H2 math concept involved. It's basically just try and solve it like geometrically lah. So this part here, you draw. We need the height, so that's important. Actually, right off the bat, you would know that because it is 120. So this was we split into half. This is 60 degrees lah. Half. Okay. You draw all the diagonals out, actually is also quite okay. So it doesn't take long for you to know that actually this is 60 degrees, 60 degrees, because 360 divided by 6 angles here, 1, 2, 3, 4, 5, 6 is 60. This is also 60. Okay. So in other words, this is a isosceles triangle lah. Equilateral triangle. Okay. So once you're done that really, you just gonna draw this down, and now you get this angle here. Ta-da. Okay, and try and make sense of it. The problem now is this is 60 lah. The problem now is you need to find what is the remaining ones lah. So then 60, 60, 60. Okay, not hard, right? This part is okay, right? So we are looking at what are we looking at? We're trying to make sense of the rest, right? So put in your H. H is this one. I think you would have already guessed that this is a H because that's your height of your hexagonal box. So if this is your H, know that you have got this whole thing here. So this thing here you can actually find. Okay, so how do you find this in terms of H? So if this is X, right, what would this be? Okay, so tangent 60 H over X. So X equals to, okay, maybe I should just write tangent 60 is root 3. Okay, so this is 1 over root 3 H. Make sense? That's one. So once you get that already, shouldn't be too much of a problem because this is also 1 over root 3 H. Okay. So let's look at this equilateral triangle here. So the side of triangle will just be A minus 2 times 1 over root 3H. So this is this side here. Okay, so this part here is that's it already. The next part would be finding the equilateral triangle, the area of one equilateral triangle. Then you times 6 lah, because you need the base area times the height. So that's one way. There are many ways to solve this. I'm just giving you like one of the way. So I'm just gonna find one area of one equilateral triangle will just be half times half AB square sine C. So the two sides are the same length. So we just use AB sine 60. In this case, the two sides are the same, so we're just going to use the same. Sine 60 will be root 3 over 2. Like that. Okay. Okay or not? Question, please ask. I let this be X. So once we're done already, we want to find the base area. Base area A will just be, should I just write this down? 6 times the whole thing. 6 times the whole area there. Okay. So some of you may wonder, how come I know to let this be X? Because you realize that this X here is the root of our problem. If you have this X, we can solve it. But anyway, you should always know that for a right angle triangle, if you have a angle and the length, any length would do. It just doesn't, one angle, one length for right angle triangle gives you the right to know everything. So if you see a right angle like that, you have the angle, you have the length, right? You should know that this length could be found because of trigo ratio. You are God to the triangle, like you play God lah for once, like you know everything about this right angle triangle. So this part here, once you done, you just multiply with 6 times because obviously one triangle is this area. You have 6 times of it, then the volume will just be times height lah. So this should be your answer lah. Then the question is, Mr. Gunn, how come this is so different from what is asked to show? Then how? This is the next part I want you to show. Okay, so how how do you actually change this to this one here? That's a question. The thing is, because you look at what look at the coefficient. The coefficient of h here is -1. The coefficient is attached to the h here. So what you need to do is remove this h. Always look at what you want. Okay. So means I need to remove away this lah, because you see this within here, but I got the h outside ma, so this is pretty safe. I got the √3, which is pretty safe also. So what I'm going to do now is I'm going to remove the coefficient of h, which is actually just 3/2√3. Remove it out, 2/√3. √3 over 2a minus h. So this is manipulation. You realize this has nothing to do with h2. This is a math manipulation. So this will be just 3/2√3, 2/√3. I'm just doing it very slowly so that you won't miss what's going on here. So this is 4/3, 4/3. So it's 6/3, 6/3, 2. Okay, so I do it. Check. Oh, sorry.